Hello students, here we have problem number 31 from chapter 6. A small spherical bed of mass 3 grams is released from the rest at time is equal to 0 from a point under the surface of the viscous liquid. The terminal speed is observed to be 2 centimeters per second. Find a value of the constant b that appears in equation 6.2. B, the time t at which the bed reaches 0.632 V terminal, and the C is the value of the resistive force when bed reaches the terminal speed. Now let's draw the picture and see how it's look like. Now the first of all, here we have a water, then the bed is actually, if you imagine it's here, now it has an initial velocity is 0 and the time initial is 0, okay? Then it starts sinking down with an velocity, okay, in a liquid. The first of all, let's draw a free body diagram for it. So when a bed is inside the water, then we have the weight of the bed, which is mg. Then here we have a resistive force will be upwards, okay, resistive force, both of them in Newton. So let's write down the given values. So first of all, what we have a mass of the bed, which is 3 grams. Then we have the time initial, which is equal to 0. Then terminal speed, which is equal to 2 centimeters per second. Then you have to find in part A, what is the value of constant b. So we have to find a constant b. Then in part B, we have to find the time at which the bed reaches 0.6. So when velocity is equal 0.632 v terminal, what will be the time? Then finally in part C, you have to find the value of resistive force when bed reaches terminal speed. So when the speed is equal to the terminal speed, what will be the resistive force? Okay, so now let's start then. The first of all, we have already the formula, which is already derived in the book, so we don't go into details, we don't derive from the beginning, but we have a formula after derivation is that velocity, actually is varying velocity, is equal to the terminal speed 1 minus e minus time divided by tau. Okay, so first of all, let's look at here. So v terminal here is equal to mg divided by the constant b. Okay, what else? So what does mean tau? Tau is a time constant, which is equal to the mass divided by the b. Okay, so that means we can rearrange this equation by saying that terminal speed is equal to the mg over b, 1 minus e minus, now if you substitute m over b into tau, what you will get? You will get a b constant multiplied to time divided by the m. Okay, here we have all formulas. Now let's start solving and finding the part A. Now in part A, we have to find the time constant b, right? So that means we have to use this equation. Let's write down, this is the first equation. Here I'll have the second equation, okay? Then here we have third equation. So in a part A, we have to find a b constant. So that means what do we have? We have v terminal, which is equal to mg over b. That means we can find a b mg divided by the terminal speed, right? So the mass is 3 grams, so it means 3 times 10 to the power of minus 3 kilogram multiplied to 9.8 meter per second squared and terminal speed is equal to the 2 multiplied 10 to the power of minus 2 meter per second. Okay, so you do calculation, and after doing calculation you should find that your terminal your constant b is equal to 1.47. the unit will be Newton second divided by the meter. Okay, so now in the part B, we have to find a time when V is equal 0.632 V terminal. So that means we have to use the formula, third formula, which means we have V is equal V terminal, right? Which is multiplied to the 1 minus E minus B time over M. Okay, so we said that when V is equal 0.632 VT, that means we can plug this velocity here, which means 0.632 V terminal is equal V terminal 1 minus E minus BT over M. Okay, so VT will be gone. Then after that we're going to have 0.632 is equal 1 minus E minus BT over M, right? Now then we have to take the natural logarithmic from both sides, and what we will get. So when we take both sides, we will get rid of E. Okay, so that means we can say that ln okay, so 1 goes there, so that means we can say that E minus BT over M is equal to 1 minus 0.632, right? So when you subtract that one, you will get 0.368, which is equal to minus, now B is in our case we already found, which is equal to this value, which is now minus B is equal 0.47 multiplied to the time and divided by the mass, which is 3 times 10 to the power of minus 3 kilogram, right? From there, if you do calculation, then you should find that it's equal to 2.04 times 10 to the power of minus 3 second. Okay, so now we found our time. Okay, so we found the time, we found the constant B. Then finally we have to find what will be the resistive force. Now we know that when the speed is reaching the terminal speed, then our resistive force will be equal to the weight, or it is equal to the mg, right? This is a true case when your velocity is reaches the terminal speed. Okay, so that means when this r is equal to v terminal multiplied b is equal to mg. This is equation valid only when the v is approaching a terminal speed. Okay, so therefore we can say that our r can be used, we can use both equations. We can use terminal speed times b, or we can use mg. Okay, so in our case let's just use the mg because it's easy, I think. So mass is 3 kilograms multiplied to the g, which is 9.8 meter per second squared. Now if you multiply this, you will get that it's equal to 2.94 times 10 to the power of minus 2 newtons. Okay, this is how you got your part C.